Okay, I think we're going to get started here. It's right on time. Welcome everyone. This is our new look greening healthcare webinar coming to you from our houses while we're remaining in the current crisis situation. This is a topic that we've addressed at a number of workshops in the past year or so, and we felt it's too important and impactful to be left out of future work. So we've designed not only this webinar for it, but it'll also be a series as this progresses over time. This is a topic of how you replace your central heating plant with a low carbon option in mind. It's something that's important because it's hopefully something that you don't have to do very often. And it does last for quite some time, the type of equipment that you replace. So you really do want to get it with the environmental impacts in mind. So during this webinar, we're going to have Q&A throughout. There's a Q&A option at the bottom, which is different than the chat. If you want to ask a question, use the Q&A and you'll see the answer come up, or we'll address it during the hospital panel. The chat is just mostly used if you have questions or issues about the webinar and want to send me a message, use the chat to do so. And other than that, I'll hand it over to Ian to get started with the agenda.
Yeah, thanks, Michael, and good morning, everybody in Ontario. Good afternoon, everybody in Ontario. Good morning to the folks in Alberta. As Michael says, this is webinar number 1 in a series on working towards the low carbon heating plant that we're anticipating will flow for at least the next two years. And different webinars are going to go a lot deeper into different areas like management practices, equipment, and so on. This one, our aim today is to provide an overview of what is the big idea, what's the conceptual framework for what working towards low carbon looks like in existing hospitals, and to set the stage for the work that will come. From the agenda standpoint, we're going to start with the why. We want to give you a sense of what governments are saying, what signals we're getting from governments, and why we should believe that this is something we've got to do, not something that we'd like to do. The background is the why. The framework is intended for every hospital in North America to begin to start working down the path towards low carbon at the least life cycle cost approach. We have 2 organizations that we think are going to be central players in the whole thing, with Nadine International and GTT Onset. And we're particularly grateful to our panel of 3 hospitals that are working down this path already. So they're starting to encounter some of the challenges, some of the opportunities. Looking forward to a discussion with them on how do we actually make this work in hospitals. And then we'll talk a bit at the end about next steps and what comes after this. Particularly with language like trigger events. By the end of today, hopefully everybody knows what a trigger event is, because that's usually when you have to start doing this kind of work. So let's talk about the climate crisis. With the pandemic, it's really hard to focus on climate. There's even the irony that that emissions are actually reduced a little bit because of shutdowns and reduced air travel. But it hasn't gone away, and 2 years from now, when the pandemic is behind us, the climate crisis will still be burning along and increasing in intensity year after year as we get more kind of weather and unnatural disaster crises. The green box here just intends to cover some of the things that are happening with governments, because the public gets it now. It's high on the priorities for the public at large, and governments are responding. So both Alberta is phasing out coal, as you know, by 2030. We have our Ontario Environmental Plan in place. We've seen carbon taxes arise, and the Climate Action Incentive Fund, which we're expecting to redirect significant carbon tax funding back to hospitals to help with the transition to low carbon. We've seen New York City pass its local law 97 with carbon caps, which include penalties if you go over the caps that would be measured in hundreds of thousands of dollars a year. And the government of Canada most recently has committed to net zero. So all the signals are pointing in one direction. The hospital sector is going to be at the forefront as this works through. So where do the hospitals look right now? This is the first time we've shown carbon benchmarking, greenhouse gas benchmarking. So the Ontario hospitals of greening healthcare on the left, the Alberta hospitals on the right, And the big difference, the Alberta hospitals are typically 3 to 4 times the emissions per square foot of Ontario, simply because of 40% of the electric grid is coal-fired. And that's the kind of numbers you see. You can barely see the greens on the left-hand side because the grid is being cleaned up. Alberta will be cleaning its grid up. So it will move everything in the right direction, but the rest of it then is down to us, and particularly down to looking at natural gas at fuel consumption. So these metrics you'll be seeing in your annual reports with Greening Healthcare. You'll see in all the reporting coming out from here on in. The carbon intensity of a hospital will become a key metric for evaluation. Let's talk about the roadmap. So the roadmap very simply has 4 stages, and we apply this model to every type of building. So step 1 from your baseline carbon is getting the most out of energy efficiency. It is the most cost-effective way of lowering carbon, and if we have to, it's the place to begin. Comprehensive heat recovery is step 2, and that's the one which hospitals have done relatively little of until the brand new P3 hospitals coming on stream now. So step 2, comprehensive heat recovery. We'll talk about how you identify and begin to harvest the huge amount of heat that every hospital rejects right through the heating season. Then increasingly there'll be focus on-site renewables and carbon offsets to make up the difference. We know of no other pathway to net zero, and it takes time, and essentially we've got 30 years to get there. The green box at the bottom is the key message. Simply to try to go to net zero or to low carbon is prohibitively expensive. It simply can't be done. There isn't enough money in Canada to make that work. The roadmap idea is we integrate the progression towards low carbon over multiple years with our capital renewal program, and we make better decisions than we might otherwise have made so that we get step by step towards low carbon. And this session is all about trying to indicate what that looks like. A priority for us right now is that every hospital have shovel-ready projects for when that carbon funding arrives, which we expect to be within the next 12 months, that you're ready to go and moving forward on that. So next step is let's talk about what the low carbon heating plant looks like, and this will be familiar to a number of the new P3 hospitals on the call because they're not all the way there, but new heating plants are being built around the idea of heat recovery chillers and so on. But the systems involve the heating systems at the top of this bar, domestic hot water, air reheat, air preheat, and the heat sources at the bottom, all the condensers on cooling units around the hospital, which are sources of a substantial amount of heat that we can harvest. With a conventional, and this is what exists in every hospital, conventional heating plant supplies those things typically from a combination of high pressure steam boilers and hot water boilers. The high pressure steam goes through pressure reducing valves and heat exchangers. It's inherently inefficient. The chilled water system very often is picking up the heat from, one of the case studies we have today we'll be talking about is picking up the heat from some of those water cooled condensers, but typically rejecting it out through cooling towers or fluid coolers. The rest of those condensers at the bottom are typically air cooled and just blowing the heat out through the roof. When we get to the low carbon heating plant, it looks a whole lot different. So it's got elements of low pressure steam. We haven't found a way yet to provide humidification other than low pressure steam. So we'll still have small boilers, we'll have standalone high pressure units for sterilizers. We've got condensing boilers, we've got heat recovery chillers drawing heat out of the chilled water loop. It's a very different configuration. And over time, we're looking to recover more heat through heat reclaim units from exhaust air leaving the building, from discharged water leaving the building, and connecting those existing air-cooled condensers to water-cooled. So all of that heat is made available to displace natural gas. So this is the transition from where we are, where we have been, to where we're going. And the reducing the, and we cannot see at the moment how in the short term we're going to get free of boiler plants altogether. We are looking at that with commercial office buildings, for example, but hospitals are going to have boiler plants for some time to come. The key is to make those new plants as small as possible by implementing, in this case, 5 if you like, elements of peak heating load reduction, so that when we do replace our plant, our boiler plant, it's right-sized to the future energy efficient load profile, which leads to lower cost installations and to more efficient plant operation. So the steps through here that are self-evident, what hospitals are working on now is to optimize the amount of outside air during the wintertime that goes into their ventilation systems to bring that peak down a little bit. Then to look at all of the exhaust air leaving the building and the intakes of air coming in, and look to get thermal wheel applications in to recover that heat. The process heat recovery I touched on a moment ago. So this is picking up all of the heat loads that are being generated within the hospital and thrown away, gathering them together and using them to supply heat. Wastewater heat recovery is we've got a lot of warm and hot water leaving the building. Can we recover the heat from there? And the building envelope, and I'm hoping that Ajwad will touch on that in Nadine's conversation. Suddenly the building envelope becomes strategic, not just because it helps reduce the peak heating load and reduce the plant size, but also because it allows, it can allow lower heating water temperatures that lead to higher plant efficiencies. So in terms of plant size, optimizing that and right-sizing the plant, this is another element of the progression towards low carbon heating. If we now look at what are all the elements, and they come in three areas. And again, the subsequent conversations will be addressing how we tackle some of these. Every hospital, I believe, in this meeting has its energy efficiency plan. It might be an ECDM plan in Ontario, the utility management plan in Alberta, and it's been identified what your operational improvements are and what your energy retrofits are. So over time, you're going to be implementing measures around energy efficiency. From the building condition assessment, you've got a whole bunch of plant and equipment which will be approaching end of life, and you're going to be looking to orchestrate how and when do you replace those things with what to work progressively towards the low carbon plant. And medical equipment is a big deal. There's a huge source of heat. You'll be working with clinical services to ensure that whatever MRIs, CAT scans, whatever are purchased, have the suitable heat rejection provisions that you can recover the heat from that equipment and use it to help heat the building. So these are the elements, these are the puzzle pieces, if you like, of your low carbon roadmap. And then the plan is, the roadmap then is, how do you put all those together with a series of projects over time? So this is going out to 2035. And up front, we've got energy efficiency, operational stuff. Why wouldn't you do that first and drive cash flow? We've got some energy retrofits. The boiler plant replacement, the red one, has been pushed back to 2031 to make time to do some envelope improvements and process recovery. So this becomes a strategic decision-making process for you to plan when you do projects, which projects, to get the best overall life cycle cost outcome. Because if we can't achieve that, we can't afford to get to low carbon over time. So this is the essence of the roadmap. The low carbon roadmap is where you begin. So all the three hospitals you'll hear from later, they've begun the elements of that. What does that plan look like? They feed into the asset management system, so that the asset management system becomes a key management tool for you to use. And when that all works out and gets adjusted and fine-tuned over time, it winds up at the low carbon heating plant that you're aiming for. All of this feeds a life cycle costing model. So essentially the table at the top, you enter your projects, your energy efficiency projects, and then the rest. You enter what the like-for-like cost would be, what the low carbon solution would be, and what the economics are on the right. And it will generate you a cash flow forecast, an internal rate of return, a net present value that you can help optimize the economic aspects of this. We've got 4 early stage projects for your consideration that help to illustrate this. With North York General Hospital, the trigger event there, and I say that's a key term, the trigger event is the high cost of city water. They actually have direct to drain condensers. The assumption was that they would convert those to air-cooled condensers to save the city water. Instead, they've connected them as water-cooled condensers to the chilled water system and recovering the heat directly into an outside air plenum that picks up a number of air handling units. So this is direct heat recovery, and you can see the economics that play out with that. Orillia Soldiers Memorial, the trigger event, is the free cooling plate exchanger that interfaces between the chilled water system and a winterized cooling tower in winter. It's at the end of life, it's plugged up, it's in terrible shape. The project here is, instead of paying $150,000 for the heat exchanger, spend $215,000 by a heat recovery chiller, and then over time, add more and more equipment to that. And you can see the economics of the low carbon solution are often very attractive indeed. For Headwaters, what Janet has there is a multi-year plan. The starting point is the fluid coolers now on Schedule A, it's at the end of life. But the rest of the plant is severely aging, and Headwaters was looking for a multi-year plan as to what's the logical sequence to do things. What is intriguing there, again, is the low carbon solution around plant replacement is actually less expensive than replacing like for like on the way through. Finally, Grand River, we touched on this a moment ago, and Greg will be talking to us later on the panel. Here with Greg, his trigger event is his hot water boiler plant at the Freeport site is supposed to be at end of life. And his strategy now is, can I extend that life so I can do some energy efficiency things, so I can put a smaller boiler plant in later than I would otherwise have had to do on a like for like basis. So that's the overview. That's the big picture. This is where we're trying to get to. And to say it's not going to be overnight, it's going to be a number of years to work our way there.